So here we are with lecture 2.3. So we're looking at the information from the graphs of functions. So the different information that we can find when we're looking at a graph would be random values, the domain and range, where it's increasing and decreasing, and also if it has any extrema, so any minimum or maximum values. So remember when we were talking about parabolas, those things were what we might call a minimum or maximum value. So we're looking at stuff like that. So here we have example 1. We're going to find values and the domain and range. So I'm given the following graph right here, and I'm asked to find h of negative 2. I've already written it down. H of 0, h of 2, and h of 3. So h of negative 2, what I'm looking for is where x is negative 2, I want to find the matching y value. So where x is negative 2 is along here, and I'm trying to find the matching y value for my graph. So I look for where, now you don't need to draw in this line, I just draw it in to help you visualize what's happening. So where are they intersecting? Right here. That is where I have the point, negative 2, comma, well, what's my y value? It's going to be 1. Okay, so negative 2, 1, so my matching y value would be 1. Okay, let me erase this to make room for the other ones we're going to do. H of 0, same thing. I'm going to go ahead and figure out where x is 0. Okay, because my input value is x. Happens right here. Where does it intersect with my graph? Right here. So this point is 0, comma, negative 1. So my h of x value, or my y value, is negative 1. Okay, go ahead and try see if you can do the other two by yourself. Pause the video and check back with me. All right, so h of 2. I'll go ahead and this time I'm not going to draw the line. I know 2 is here, so I'm going to go up and find my graph, which is right there, and I'll just plot that point. That's going to be 2, comma, well, the matching y value is 3. So h of 2 is going to be 3. Okay, I'm going to do the same thing for the next one. Let's see, h of 3. So let me erase this. H of 3. So here's my 3 value. I'm going to go up and find my graph right here. Plot that point. That's going to be 3, comma, well, the matching value on the y would be 4. So h of 3 is 4. All right, find the domain and range. Okay, so domain, remember, those are the x values we use. So I'm going to go ahead and write dome of h. Oops, and as I said it, I wrote f. Nice. Okay, domain of h. And normally, you'll write an interval notation unless stated otherwise. It's just sort of a habit. So, domain, we read from left to right. So what's the starting number I start with? Negative 3. And I go till 4. And I include both of my endpoints. So domain is going to be negative 3 up to 4. And let's see, range of h. Okay, go ahead and see if you can find the range. Well, the range, you're going to start with your lowest y value, which is negative 1, and keep going until the highest y value. Well, you might be tempted to stop there, but remember, we also have this y value here. So we go from negative 1 up until positive 4. Those are all the y values. If it helps, sometimes I like to turn my page and just do the same as I would with the domain. So it goes from negative 1 to 4. Okay. And we're including both of the endpoints. All right, so now we're going to find the values of x for which h of x is equal to 3. Alrighty, so let's see, h of x, oh, same thing as we kind of did before, but a little different. This time, we're given the y value is 3, and we're searching for the x value. So what I'm going to do is I'm going to go where y is 3, which is right here, and I'll just draw my line through it. Oh, interesting. Look how many times y equals 3. 1, 2, 3 times. So there are 3 x values that create y equal to 3. And what are those 3 x values? Well, negative 3, 3 is 1. The next one is, what is that, 2? 2, 3, and let me erase this because that's from a different problem. And the other one right here is 4, 3. So we have 3 x values that have the y coordinate of 3. So the x values for which h of x equals 3 are x equals negative 3, x equals 2, and x equals 4. All right, so find the values of x for which h of x is less than or equal to 3. Well, when y is less than or equal to 3, that's going to be all the values below here. So the values of x for which h of x is less than or equal to 3 is anything from this interval section up till this interval section. So I'm going to go ahead and erase this to fit into my graph. But notice, these points here, those create y values that are bigger than 3. So we're not going to count those. Okay, so let's see. So the y values that are less than 3 are all the ones in here. Okay, all those y values are bigger than 3. So what are the x values that create this interval here? Well, it goes from negative 3 up until 2. So the values of x for which h of x is less than 3 are x equal to, or actually let me just do it as an interval. X between 3, oh no, that's 2, 2, and negative 3. So all these points along that red line there, those all have y values that are less than 3, but once we hit here, they change, and our y values start to be greater than 3. Okay. All right, here we go with example 2. Graphing the two functions and find the domain and range. So I'm just going to go ahead and, for the first one, that's quadratic. I know that because of the x squared. So I'm going to find my vertex. That's an important point to find. So to find the vertex, we're going to do negative b over 2a, which is going to equal, well, the b value, we don't have a b. So that's going to be 0 over 2, which is going to equal 0. And then to find the y value of my vertex, we're going to plug it back in. So f of 0 is going to equal 0 squared minus 1, which is going to equal minus 1. So there's my vertex minus 1, and notice that will also be my y-intercept. Let me write vertex here. Okay, so vertex and y-intercept, 0, negative 1. I'll do a v for vertex, and then let's go ahead and find my x-intercepts. Okay, since we already found the y-intercept right there. It's the same thing as the vertex. X-intercept, set y to 0. So 0 x squared minus 1. Solving for x, square root both sides. Remember that plus or minus. And we get plus or minus 1 equals x. So we have two x-intercepts. Negative 1, 0, and 1, 0. Okay, plotting those points. 1, 0, and negative 1, 0. All right, and now I can go ahead and sketch in my graph. Okay. So let's see, the domain and range from this one. Oh, you know what, here, I'm going to go ahead and find one more point, because I actually want to have 5 points for my parabola. So I'll pick a random value for my x. Let's see, 2, and see what I get for f of x. That's going to be 2 squared minus 1, which is going to equal 4 minus 1, which is going to be 3. So 2, 3. 2, 1, 2, 3. Ooh, look at that. I was almost spot on right there. 3. And then using the axis of symmetry, I know that there exists a point, the exact same units to the opposite direction. Right there. Okay, so now I have my 5 points for my parabola, and I'll go ahead and clean this up. So I found the 5th point using the axis of symmetry, or the line of symmetry. All right, so now let's find the domain. Well, the domain is the allowable values from the x's. So that's actually going to be negative infinity to positive infinity. Okay, so the domain of f is going to be negative infinity to positive infinity, because remember, for parabolas, we slowly keep opening wider and wider and wider as we go up. So eventually all the x values will be used. We just don't have enough graph paper to do that. Now let's find the range. Okay, so let's look for the lowest y value. The lowest y value is, -1. And then what's the highest y value we use? Well, notice this arrowhead indicates that it keeps going higher and higher and higher and higher. So, positive infinity. So our range of f is going to be, we started at -1, we go to a positive infinity. All right, let's take a look at the next function. Let's plot some points here. Okay, let's see. Let's do some intercepts. So when x is 0, y is going to be 0 plus 2, so the square root of 2. And then let's pick a value that would be good to make that a square root. So how about 2? It's going to be square root of 2 plus 2, which is going to equal square root of 4. Oops. Since I'm running out of space, let's go ahead and do 2. How about another one? 3. Why not? It's not going to be pretty, but we'll do it. 3 plus 2, square root of 5. And then let's find the y-intercept. So I'm going to make some space for my y-intercept here. So solving for my y-intercept, my x-intercept, we're going to set y to 0. Squaring both sides. So we have 0 equals x plus 2. Then subtracting 2, we get -2 equals x. So that's my other point, -2, 0. Let's graph these. 0 square root of 2, well, the square root of 2 is a little bigger than 1, but smaller than 2. So how about let's do 1.5. So 0, 1.5. And then the y-intercept is going to be -2, 0. So the x-intercept is -2, 0. That's 0 root 2, -2, 0. What other points do I have? I have 2, 2. It's 2, 2. And the last point, 3, square root 5. 1, 2, 3. Square root of 5 is a little bigger than 2. All right, and there we go. There is our graph. And for our domain, we could check our graph, or we could go ahead and test the points under here. We know that they cannot be less than 2, because if they were less than -2, this would start to become negative numbers. Okay, so my domain of k is going to be from -2 to positive infinity, including -2. And my range of k, well, starting at our lowest y value, 0, and then it goes until, well, technically this graph is going to be ever growing higher and higher and higher and higher and higher, which means our y values will slowly be getting higher as well. So from 0 to positive infinity. Okay. Next, finding intervals of increasing and decreasing. Okay, one really big thing to note here is this is going from left to right. Okay, just like how we read books from left to right, we say finding intervals of increasing and decreasing. We do not say gnigsgered and gnigskri. Okay, we don't read that way. We read from left to right. So we're going to look at intervals from left to right as well. Okay, so it says f is increasing on what intervals? So looking at our graph here, we're going to go on our graph from left to right, and what happens is, look for the change in your graph first. So it changes, it switches bloop, here. So that's going to be a change, and then it changes bloop, there. Let me do that in another color. So boop, boop, and it changes right here. Okay, so we have 3 changes in our graph. So I need to determine if that's an increasing or a decreasing. So reading from left to right, is this going up or down? That's going up. So we're increasing on the interval. Let's see, that looks like it's, we're just going to say, I'm going to say these are in infinity. Okay, so increasing on the interval, negative infinity to, we stop here. This is where we switch. So what value is that? 2. So we increase from negative infinity to 2. And on what other interval? Well, that's a decrease. We're going down. Ooh, but then we start back up here. Another interval. So we start increasing at 4, and we keep increasing until here when we switch. So what point is this? That is 5. We're also increasing on 4 to 5. All right, f is decreasing on what intervals? Okay. So let's see, we're decreasing on these 2 intervals. That's when we're going down. So the interval I'm decreasing on is 2 to 4. And the other interval I'm decreasing on is this one right here, which is 5 to, well, that goes on to infinity, so positive infinity. Okay. All right, so example 4. Let f of x equal x to the third power plus or minus 5x squared plus 2. And we're going to graph this with our window, which is given, and we're going to find the intervals of increasing and decreasing. Round to 1 decimal place. Okay, so go ahead, pull out your calculator, and go to the y equals section. Okay, and let me zoom out. So we're going to graph 2x cubed. So here we go, 2x to the third power. I'm going to hit this button to go down. Minus, so let's hit our minus. Remember, this is the minus, that's the negative. So minus 5x to the and second power 2. Hit this, go down, and then plus 2. Okay, we could go ahead and hit graph for fun to see what that's going to end up looking like.